everyone. So in the last video we discussed about the theories and formulas of queuing model. So what are the theories? Some formulas? Some formulas were like this. We thought about utilization factor. We learned about the utilization factor, which is nothing but lambda upon mu. It is nothing but the probability that the system or the server is working or it is not idle. Then P naught is the probability that the server is idle. It is given by what? 1 minus rho. Then Pn is the exactly n number of customer is in the system. So what is the probability of having exactly n number of customer in the system is given by this formula. P naught into rho to the power n. Then length of the system or average number of customer in the system over a period of time or is given by this formula. Rho upon 1 minus rho. Then LQ. LQ is the average number of customer in the queue. It is given by this formula. Then average waiting time in the system is given by this formula, and average waiting time in the queue is given by this formula. This is the average waiting time in the queue. Or you might say difference of average waiting time between system and in the queue is nothing but the mean service time of a customer, because 1 upon mu is nothing but mean service time of a customer. Got it? Mean service time of a customer. Now we will solve some numericals. So this is the first one. This came in IS 2004, I think, 15 marks. In a machine shop, machine breakdowns at the rate of 6 machines per hour. So, and the cost of each idle machine is rupees 300 per hour. Repairman, there are two repairments, A and B. They are having different skills. Repairman A takes 6 minutes on an average to repair a machine. So he needs 6 minutes to repair a machine, and his salary is rupees 150 per hour. In 1 hour, he will get 150 rupees. Then repairman B with different abilities, skill takes 5 minutes on one machine, and so his salary is more, 200 rupees per hour. Then shift duration is of 8 hours. So question is, whom we will select, A or B? Okay, let's solve this one. So what is the arrival rate of machines? What is the arrival rate of machines? Arrival rate of machines, it breaks down at 6 machines per hour. So lambda is nothing but 6 machines per hour. What is idle machine cost? Idle machine cost is rupees 300 per hour. Now, first we will talk about A, requirement A. So for A, it is given that he takes 6 minutes on an average. So his mean service time is given by 6 minutes. Got it? So if 6 minutes, so what is the service rate by A? What is the service rate? So service rate by A is 10 machine per hour. Got it? So we can repair 10 machines per hour. 60 divided by 60 minutes divided by 6 minutes. Okay. So what is the system utilization? System utilization is lambda upon mu, or you can say lambda is 6, mu is 10. Okay. So now each idle machine will cost rupees 300. Now machines are entering the repairman shop. So when a machine is in repairman shop, it is a repairman shop. Machine is in repairman shop. It cannot provide service. So whether it is in queue or it is getting service, it does not mean. It doesn't mean anything. It also can provide service. It also cannot provide service. So we have to find out the average number of machines average number of machines in the system, not only in queue. You may think this one is getting service, so it will provide. It is getting service, so it will provide service after repairing is done. No, but this one is also being serviced. So at that point, it cannot provide. This machine cannot provide service. Similarly, they are in queue. They are also damaged, so they cannot provide service. So all of them who are in the system cannot provide service. So they are basically an idle machine. They are idle machines. So we have to find out the average number of machines, idle machines, average number of machines or length of the system per hour. So that is given by, length of the system is given by rho upon 1 minus rho. Rho is nothing but your 6 upon 10, and this is 1 minus 6 upon 10. 10 gets cancelled out, 6 upon 4 equal to 1.5 machine. That means on an average per hour 1.5 machines are in the system. So they are idle. So they cannot provide, on an average per hour 1.5 machines cannot provide service. Okay. Now I will wrap this one. Okay. Now, so what will be the total idle cost if A is working? Length of the system for A, put on, multiplied by idle cost per hour into shift duration. Okay. What is the length of the system? 1.5. Idle cost is 300 per hour. And what is the shift duration? 8. So this much rupees. If I 450 into 8, 3600 rupees. So total idle cost is rupees 3600. Now, what is the salary of A? Now, what is the salary of A? Rupees 150 into 8 is nothing but rupees 1200. So, total cost if you select A is rupees, this plus this, rupees 4800. So if we select A, we will be having expenses of rupees 4800. Okay, got it? Now rupees 4800. Now for B, lambda is nothing but your 6. Mu is your, he takes 5 minutes on one machine. He takes 5 minutes on one machine. So in 1 hour he can repair 12 machines. So lambda mu is equal to 12. So rho is equal to lambda upon mu is nothing but 6 upon 12 equal to 0.5. So length of the system is rho upon 1 minus rho is nothing but 1. So total idle cost will be equal to length of the system which is 1. Total idle cost per hour is 300 and shift duration is 8. So rupees 2400. And B's salary is 200 into 8. So rupees 1600. So total cost, if we select, total cost if we select B is 2400 plus 1600 is rupees 4000. So for A we are having expenses of 4800 rupees, for B we are having expenses of 4000. So we will prefer B. Got it? Not done. Okay. Next we will solve some questions asked in GATE. Okay. This is GATE 2014. Jobs arrived at a facility at the rate of 5 in 8 hours. In 8 hours. The arrival of next, the average service time, the average service time of a job on the facility is 40 minutes. Question is idle time in hours at the facility per shift. Remember, per shift will be. This is a 2 marks question. Option A is given as 5 upon 7, B is given as 14 upon 3, C is given as 7 upon 3, D is given as 10 upon 3. Okay, let's solve this one. So what has been told? Jobs arrive at the facility at 5 in 8 hours. So in 8 hours there are 5 jobs. So in 1 hour, how many jobs? 5 upon 8. So 5 jobs in 8 hours. So in 1 hour we will have 5 upon 8 jobs per hour. Got it? Mu is given as, okay, for one job they take 40 minutes. So in 1 hour, how many jobs will be? So in 1 hour, how many jobs will be repaired? 16 upon 40 jobs per hour, or you can say 3 upon 2. So what will be the system utilization? Lambda upon mu, or 5 upon 8 divided by 3 upon 2, or you can say 5 upon 12. So this much time system or server is working. So we can calculate the probability or the time that server is not working, that is 1 minus rho. So we will get 7 upon 12. Got it? Okay. Now student will commit mistake here. He may ask, answer is not given in the option, and so he thinks this is the answer, this is the time system or server is not working, and we have been asked the same. What is the idle time in hours at the facility? So this is the idle time, 7 by 12, it is not in the option, so it is wrong, it must be wrong question, we will get the marks, bonus marks. No, not so. Read the question carefully. It has been told that idle time at the facility per shift and one shift consists of 8 hours, not 1 hour. It consists of 8 hours. So total idle time per hour will be 7 by 12 into 8 equal to 14 by 3. So option B is correct. Got it? So always read the question carefully. Next one. Done? Okay. Now, next question is, this was also a question, this is also a question from GATE, 2 marks. A maintenance service facility has Poisson arrival rate, exponential service time, and operates on first come, first serve. So, arrival rate pattern is Poisson, service is exponential, and service order is first come, first serve. It says that breakdowns occurs at an average of 3 per day. Breakdown occurs at the rate of 3 per day with a range of 0 to 8. The maintenance crew can service at the rate of 6 machines per day with a range of 0 to 7. The mean waiting time for an item to be serviced would be, options are 1 by 6 day, option B 1 by 3 day, option C 1 day, option D 3 day. This was asked in GATE 2004. I think IT Delhi. Okay. So what is the question? Breakdown occurs at the rate of 3 per day with a range of 0 to 8. Per day, 3 machines breakdown. Okay. Maintenance crew can service at the rate of 6 machines per day. In one day, they can repair 6 machines. Now, what is the question? Mean waiting time for an item to be serviced would be. Okay. So you have been asked about the waiting time. Now, okay, you have been asked about waiting time, but we have got 2 waiting time. What is 2 waiting time? One is waiting time in the system, one is waiting time in the queue. But it is not specifically mentioned whether it is in the system, whether it is in the queue. There is no mention of system or queue in the final sentence. So, which one we should consider? Waiting time in the system or waiting time in the queue? Okay. Which one? Consider. The answer of this entire question, 2 marks, depends only on one word. That word is mean. If you observe, if you notice this word, then your answer is hidden in this word itself, within this word itself. Always remember, if in any question there is no mention of system and queue, but there is the mention of the word mean. Note down this one. Note down. If there is a mention of word mean, that means you have been asked about waiting time, average waiting time in the queue. Very, very important. You have to remember, if the word mean is there, then you have been asked the waiting time in the queue. Suppose mean is not there. You have been asked the average waiting time. You have been asked the average waiting time for an item to be serviced would be. Again, there is no mention of system and queue, but the word itself describes it. Average. If the mention of average is there, this word will tell you that you have been asked about the waiting time in the system. So you have been asked about WS, average waiting time in the system. So mean means queue and average means system. Always remember. Then your question is one line. You can easily solve it now. Got it? So mean means queue. So waiting time in the queue is nothing but lambda upon mu or into mu minus lambda. Mu minus lambda. Lambda is your 3. Mu is your 6. 6 minus 3. 3 gets cancelled out. 1 upon 6. There. Got it? So A is the answer. So always remember, mean means it is us telling about queue, average is telling about system. Okay. Let's proceed to the fourth numerical. And very important one. Okay, next question. So what is given in this question? Single server queuing model where with Poisson's arrival lambda equal to 4, mu equal to 4, and it is saying that numbers in the system are restricted to 10. Find the probability that a person who comes in leaves without joining the queue. That means maximum person allowed in the system are 10. And when a person will leave the system without joining the queue, when he will observe that the system is already full, system is already having 10 customers, so then he will come and leave the system without joining the queue. So if we find out, so 11 person if comes, he will not join the queue. So if we find out the probability of having exactly 11 customers in the system, then we will get the answer. So lambda is equal to 4, mu is equal to 4. So lambda is equal to 4, mu is equal to 4, rho is equal to lambda upon mu equal to 1. Now we know that summation of all probabilities is equal to 1. N is from 0 to 10 because there are 10 persons allowed. So P0 plus P1 plus P2 plus P10 is equal to 1. Implies as P0 plus P1 is nothing but P0 all into row plus P2 is nothing but P0 into row square plus P0 into row to the power 10 is equal to 1. Now if we take P0 as common, this is 1 plus row square plus row cube plus row to the power 10 is equal to 1. Okay, got it? Now P0 1 plus 1 plus 1 is equal to 1. So P0 कितना टर्म है? There are 11 terms. This to this 10, this one is 11, and row is nothing but 1. So P0 into 11 equal to 1 implies P0 equal to 1 upon 11. So what will be the probability of having 11 customers in the system? P naught into rho to the power 11. P naught is 1 by 11 into rho to the power 11, 1 to the power 11. That is 1 by 11. So 1 by 11 will be the answer. Got it? So questions may be in this form also. Not always in this form. LS, LQ, Pn is equal to P naught into rho to the power n. It may be in this term also. Summation of all the probabilities is equal to 1. Okay, not of this one. So these are some very good questions regarding queuing model. We have discussed 4 numericals and very good one, high standard one. So you get this type of questions in exam also. So you can easily score 2 marks, I think. So this is all about queuing method. So starting from that system, we are up to this. I think you have understood all the things. Very small chapter, interesting one, but this is a scoring chapter. You can easily score 2 out of 2 marks from this chapter, and this chapter is very important from the point of GATE. Okay, thank you. In next video we will start some other topics. Thank you.